All right. Sorry for the delay. For anyone who's trying to tune in live, the software forced an update on me, and then I had issues with internet connection as well, so it took a little bit to get going, but here we are. It is Thursday the 16th, and we finally get to really start some of the actual real trig pieces of trig. We're going to work through kind of some pieces from section 9.4. It's only one section for this week, and it's going to kind of be that way. Portions of it can be tricky. I'll have an assignment at the end that I'll share with you. It's already a little bit tricky, so please, if I ask you to do something with the video or like pause and then try something on your own, please, 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 please take the time. Actually try some of that stuff. It is going to make a difference here, okay? So I mentioned that we're starting something called right triangle trigonometry. That's kind of what this whole unit's about, and the first parts are things that we're going to need in support of that. There's going to basically be four, and you'll typically hear them in this order. Three. Math teacher can't count. Apologies. Sine, cosine, and tangent. Okay, and again, those words are sine, S-I-N-E, cosine, C-O-S-I-N-E, and then tangent. And all three are ratios based on an angle in a right triangle. So we did all that work with right triangles to establish some patterns and some things around these, and those things do tie in as well. We're going to be looking at one of the angles that is not the right angle and seeing sort of what ratios occur. And there's wild, wild uses for all of these sorts of things. Like anything having to do with waves is all based off of understanding how these trigonometric functions like sine, cosine, and tangent work. Okay? So first up, we got one of those turquoise slides here. So that's going to come in play in terms of this is basically sort of your toolkit things here. What I'm saying here is this phrasing is pretty critical. You're not going to have to necessarily repeat this so much, but I'm going to showcase what I mean and how people often make a mistake with this. So it says the tangent of an angle is the ratio of the opposite side over the adjacent side. So what that means is you see that right here on this equation, this will come up on a later page as well. I'm saying tan, T-A-N. You will hear that a lot. It is a shortened form of tangent. When we talk about sine and cosine, the other two that I mentioned, there's also shortened forms of those that all use 3 letters. So that's a pretty common convention. If you just have TAN on its own, that's you going outside, maybe not on a very snowy day like this, but getting just more melanin, okay? It has to be tangent and then have this angle right here. Now I'm introducing something here called theta. It's a Greek letter. In the Greek, like their first 2 letters of their alphabet are alpha and beta, which is where the word alphabet actually comes from. Theta is just another letter. It's pretty common to use some of these things, and we might have done a little bit already with Greek letters for angles here. I'm saying that the tangent of that angle, so it matters what the angle that I want the tangent of is going to make a difference. It's the opposite side, which I have here matched in red. So from the perspective of this angle, it's looking to that opposite side. No part of this angle touches that side. Divided by the adjacent, which is going to be a side that touches the angle, but it's also never the hypotenuse. The hypotenuse is always that angle opposite the 90, so it should be your longest side. We're not going to use that in tangent at all, okay? They will come back, the hypotenuse will, in sine and cosine, which we'll get to in sort of next week, all right? Let's put this to use a little bit, all right? There is a little bit of an exploration. I'm going to kind of give some of these links, and I'll update the post later with them if you want to kind of work your way through. I'm going to click on some of these for now just to showcase a few quick things. I got to pull this over here. Come on. So what I'm loading here is basically like we've got a triangle built, okay? And there's sort of 2 different sliders, this A and this B value here, where I can basically change them. A is going to basically change, oops, as I play it. What it's really doing is changing one of these side lengths here, okay? And there's a lot of programming, you don't have to worry about it too much. It's basically changing the side length and maintaining, as I change this side length, my triangle gets smaller, triangle gets bigger, this angle right here has been 56 the entire time. That hasn't changed, not one bit. The ratio, if I'm basically taking my opposite side, I'm going to pause it right here, 8.52 divided by 5.75, put that in a calculator. You know what you're going to get? 1.48. If I change this a value so the triangle now gets bigger, I'm taking the opposite side from that angle. I'm looking from 56 to the 9.81 divided by 6.62, comes out to 1.48. Let's make it a smaller triangle. From that opposite side, if I take 5.01 and divide it by 3.38, you want to know what you're going to get? 1.48. Really, it doesn't matter what size this triangle is. I can make the side lengths as big or sort of small. As long as that angle is 56, we have that right angle at B, this ratio doesn't change. Now, I'm going to change B, which is going to change this angle here. So as we play this, right, we went up to 60, now we're kind of decreasing. Watch what happens. As I get smaller with the angle, look what happens to this ratio, my opposite side and adjacent side. You'll notice this 3.3 is going to stay. That guy's not going to change. All that's really changing is the opposite side. The angle gets smaller, so does the opposite side, but the adjacent side doesn't have to change. The angle determines how big the opposite side is, something kind of from last week. It's not going to affect the adjacent side. So we see that a smaller angle ends up giving me sort of a smaller tangent. Bigger angle, give you a bigger tangent. You can go in there and play around with that a little bit if you'd like. The main two takeaways I want you to get from that are, with the same angle, the size of the triangle doesn't change that ratio. So I could have a triangle that is bigger than Earth, and as long as I know the angle, tangent's going to be the same ratio. Or I could have the smallest one in the world. Doesn't make a difference. Smaller angles have smaller tangent ratios. Bigger angles have bigger tangent ratios. Okay, you can play around with that a little bit if you like. Let's move on now. So on page 542, you're going to see kind of another way of phrasing that same stuff that I had in that toolkit slide there. Again, just stressing the idea of what is tangent. It's a ratio written as a fraction of the opposite side, which, because you can't use the hypotenuse, has to be a leg, one of the two sides touching the 90-degree angle, divided by the adjacent side, which is also a leg, also touching 90, but it also shares the same, or touches the angle that you're talking about. This example here on page 542, we're referring to like angle A. If we did angle B, and we're going to get to some of that sort of stuff, it's going to change the order of these things a little bit, okay? So, I've got an example here, and I would recommend kind of copying this or printing this sort of thing out for a toolkit if you'd like. Page 542, example 1. We're asking you to find tangent of S and R. So it's kind of two problems in one. Find tangent of S, do all the work for that, and then later find tangent of R. It says write each fraction, or sorry, answer as a fraction and each decimal rounded to 4 places. Let me pop my Streamline stuff back up. Okay. Here's how this is going to go. Let me copy something from a previous page here because I'm going to need this. Tangent of some angle is always the opposite side divided by the adjacent. If I'm starting with tangent of S, I'm going to change theta to S. That's my angle that we're talking about here. From angle S, which in this case is sort of that top left angle, the side opposite from that guy that doesn't touch it at all, it's 80. So I'm going to replace opposite right here with 80. What side length, which again, one of the legs, is adjacent to angle S? It touches this angle, 18. So I've got this fraction, 80 over 18. Ideally, you would reduce that. I can divide, both of them by 2. This guy's going to go to 40, and this guy's going to go to 9, and that's about all I can really do. And I can copy this guy. Let's add another equal sign in here. Right, if I reduce it a little bit, that's about all I can get. 40 and 9 aren't going to share anything. I'm just dividing both of these numbers by 2. So that means tangent of S is equal to 40 over 9. It says a decimal rounded to 4 places. Let's pull up a calculator. Let's actually do it. Calculator went on the wrong screen there. I'm going to do 40 divided by 9. Well, all right, round to 4 places. We've got a bunch of 4s here, so it's going to be 4.4444. This fifth 4 is going to tell that one to basically stay. So I could also write, I'll just write the whole thing. I could also say, oops, sorry, computer's going a little slow. Tan of S equals 4 point, and then 1, 2, 3, 4, and that last guy didn't round there. I could show you that the 80 divided by 18, same number. So I just reduced that fraction. Okay? Move this guy off to the side. That's tangent of S. If I now ask for tangent of R, here's how it's going to look. I'm going to basically copy some of this first part and just modify some of these. Tangent of R is going to basically change the order that we're approaching this in. R is now this bottom right angle, so what side is opposite from R? This guy right here, 18. What side is adjacent to it? What side is touching R, but it's not the hypotenuse? That's your 80. So what it's really going to do is basically flip these guys around. You can probably figure out what's going to happen to this 40 over 9. It's now going to flip into 9 over 40. And if I were to figure out what this guy is as a decimal, again, pop back to the calculator, no problems. What is 9 divided by 40? 0.225 exactly. So that one just stops there. No rounding necessary. That's it. That's what we're looking for. Order makes a difference. It is always the opposite side, but that idea is I don't want to phrase it, like, it's relative. What is opposite from S and what is opposite from R are both different to each other. So you have to kind of like look from that angle, find the side that is not touching the angle at all. In this triangle, 18 and 82 are both forming S. They're both touching angle S. 80 isn't. That's the opposite side. So if I jump to the next part here, this is page 542, monitoring progress problems 1 and 2. I've got 2 examples here, and then have the decimal rounded to 4 places. I would ask that you go ahead and pause the video right here. If you're watching it live, then we'll just kind of go along for that. But otherwise, pause. Try these for a quick moment, and then when you're ready, come back and unpause, and we'll see how you did. All right, so I'm going to go ahead and reveal this now. If we unpause these, tangent is still from any angle. It's the opposite side over the adjacent side in a right triangle. If I'm looking from angle K, or sorry, I started with J here first, my opposite side is 24, because no part of 24 is touching the angle J. The adjacent side is 32. It's touching. It's also the other leg, and it's not the hypotenuse. I can reduce that to 3 over 4. You could type, and I skipped the decimal portion for this. You literally type 3 divided by 4, you're going to get 0.75. Tan of K is going to basically do the same concept. We're going to change the order, because opposite from K is now the 32. The adjacent to K is now the 24, so you'll notice it's the same fraction. It's just the reciprocal. We took the fraction and flipped it around. Same sort of idea for problem 2 there, except with problem 2 we have 8s and 15s. You can see tangent of J is going to be 8 over 15. My opposite side doesn't touch J at all. The adjacent side does, but it's not the hypotenuse, so 8 over 15. Type it in a calculator, get a number, hooray. Tangent of K flips the order of that. Its opposite side is now 15 and the adjacent is 8. Cool. Okay. This guy right here, oops, sorry. I switched the order of these. Oh no. Well. Oh well, that's fine. I meant to have these things on here. But mistakes are going to happen. That's fine. All right, great. We have page 543, example 2. And I've got this problem here where we're basically asking for, I got all goofed up, you to find a side length. Now we're asking you to find x. Before, we've always known that. We were just saying sort of what tangent is. We are going to need a calculator for this. And I'm going to show you a couple things here based on how you might use some of these calculators, okay? I'll post this link as well, this desmos.com/scientific. It should be enabled through your Clever assignment as well. If I go here and then load this, you'll notice right here it has this degree thing. It says DEG. It defaults to that. Now, if you click it, it's going to turn something to rad. It doesn't mean it's like cool. It's radians. It's another way to measure angles that we're not going to mess with right now. It has to be in degrees. By default, it is. So if you just go right to this link, desmos.com/scientific, it will appear in degrees, which is good. If you somehow switch that mode, all of your answers are going to change, even though your process might be totally valid. So be very careful for that. I'm going to show you how to do the same sort of thing. If you have like a TI-83 or 4 at home that you want to use, I'm going to pull up a digital version here. So excuse me real quick. I can share some of this sort of stuff with you. I'm going to use a program called WabbitEmu. Go ahead and type that out for you. I have been able to get this on an Android device. From what I understand, people have also been able to get versions to work on iOS and Macs as well. If you search for this, they basically give you what's called an emulator. So we've taken the calculators that we have and been able to like download the software, and then this allows you to run the software on there. So I'm going to go ahead and open it up. Where are my downloads? There we go. And voila, there's your calculator. If you have a TI something calculator, you probably haven't ever messed with this. This sort of mode button right here, just to the right of second, if I click that, by default, like if you just reset a calculator, this third option here, it's flashing on radian, and then to the right it says degree. If you're going to use one of these, you need to intentionally click to the right, and then hit enter to turn degree mode on. I'm going to show you the difference here, okay? Right now, well, actually, we'll do the problem kind of two ways and showcase what this looks like. All right, I'm going to move the calculator off screen. We're going to go back to this. This is going to require a calculator now that we've at least established this idea of it has to be degrees. Let's actually go through solving it. You'll notice that this is now on turquoise. Cool. This is a toolkit one here. I'm still going to use all of that same equation. Okay, I'm still going to use, I should actually go ahead and copy it over here. Oops, well, okay, I'm just going to kind of write it out. We'll do it live. My tangent in this case is still always going to be my opposite side over my adjacent side. Apologies. Oops. I'm going to set this up, but it's going to be a little bit different now in terms of figuring some of these things out. Let's make this a little bigger, huh? Yeah, there we go. All right. If I copy this exact same setup that I have right here, tangent in this case, well, I've always said tangent was the angle. In this case, we actually know very literally the angle. So I'm not going to put a letter this time. I'm going to put 32 degrees. Now, that's still equal to the ratio of the opposite side divided by the adjacent side. The opposite side in this case, it's that 11. It's that side that's not touching any portion of it. And then my adjacent side here ends up being x. So we've got basically this fraction here that we got to solve for. We got to figure out how to get x by itself. With x in the denominator, what I'm going to do, I'm going to switch the pen here, multiply both sides by x. What that's going to do is cross cancel these guys on the right side because it's basically x over 1. So what I now have is x times tangent of 32 equals 11. And you might think, okay, now I've got x by itself. Tan of 32 is just a number. I promise you. We're going to use the calculator here in a second to figure that out. Just a number, nothing crazy about it, all right? So what that means is, like, if this was 2 times x or 4 times x or x times 5, it's being multiplied. What are we going to do to get rid of that? Divide. I'm going to divide both sides by tan of 32. If I divide both sides by tangent of 32, on my left side, tan of 32 and tan of 32 are going to cross cancel. So what that's going to end up giving me is, oops, x equals 11, and then I still have, it's still divided by tan of 32. Here's where the calculator is going to come in handy. Okay, I'm going to bring the calculator back over. So right now I'm still in degrees. If you leave it once until you reset or you run out of battery, it's going to be fine. You don't have to mess with that. I'm literally going to type 11 divided by, and then tan is right here, just one up and to the left from where the division button is. If I hit tan, it already starts that parenthesis for me. It's expecting me now to put in the angle. We know that it's 32, so I'm going to type 32. And then, depending on version, you absolutely have to, and it's just good practice, close the parenthesis right here. So what the calculator is going to do is it's going to figure out from those like ratios that we saw in the Desmos thing, it's going to be able to know exactly what tangent of 32 degrees is, no matter the size of the triangle. And then we're using that to figure out an unknown side length. If I hit enter, great, 17.60, let's say 4. So what is x going to really equal? Let's say 17 point. There you go. There's your missing side. Kind of fill this up here. That's the process. Now, I'm going to show you what would happen if you were in the wrong mode. I'm intentionally going to change it back to radian. And if I type the exact same thing, 11 divided by, remember tangent's right here next to the division sign, one up and to the left, 32. Okay, my dogs are excited about something. If I divide it now, we get a different number. And it might not seem like it's that different, and for 32, it doesn't happen to be. There are other numbers where this will make a dramatic difference. You've done everything right, but if your number comes out wrong, you probably wouldn't even know. Be very careful that anything we're going to be doing is going to be in degrees. The whole rest of this class is all going to be in degrees, okay? All right. We're going to skip this guy. We might come back to some of these for now. On page 543, number 3 and 4 for the monitoring progress, I'd say give one of these guys a try. Okay, we're not going to worry about number 5 here. Find the value of x. I'd say take a moment, try and pause the video and do it sort of yourself and see, are you able to come up with the same answers here? So I'm going to basically copy some of the work over here and work my way through this. Oof. So let me make this a little smaller so we can fit all of this. Okay, we'll go a little bigger. All right, I only have one angle here. I only have information about 61. So that's probably going to be my angle. And there might be situations where you have a little bit more and you have to do a little more sort of thinking for these. But for now, 61 is my only angle. What side is opposite from the 61? 22. And then what side is adjacent to it? X. I'm going to repeat that same sort of algebra as before. If I multiply both sides by x, they'll cross cancel on the right side. On the left side, I'm going to end up getting x times tan of 61 equals now 22. So what am I going to do to basically get x by itself? Divide both sides by tan 61. It is just a number, a weird decimal. If I go through and divide both sides by tan 61, let me cross cancel these tan 61s on the left side. So now I've got, oops, x equals 11. I'm going to do a horizontal, or sorry, slash, even though they're not my favorite here. Divide by tan 61. To figure out what that is, you're going to go to the calculator. Bring it back over. Oh, I'm sorry, I said 11. It's 22. I don't know what I'm doing. I had the previous numbers in my head. My apologies. Bring this calculator back over. If I do 22 divided by tangent of 61, just a number there. Let's see what we get. 5.877. There's your answer. That's it. You're done. That's how long that other side is. If this guy's 22 and this angle 61, because we're using some of those tangent ratios, which we saw are always the same no matter the size of the triangle, 22 divided by this number for 61 degrees is always going to be the same thing. That's why we can work backwards. If we now pop over to number 4, get rid of some of these other pieces here. We've got, in this case, tangent of 56 now. The opposite side here now is the x. The x is the opposite side, and the adjacent side is 13. What am I going to have to do to get x by itself? It's being divided by 13, so if I multiply both sides by 13, it literally, all I have to figure out now is what is 13. I'm going to write tan 56 because that implies multiplication if they're sitting right next to each other. It's a little smaller. This is time for the calculator. I don't know what tan of 56 is, so let's bring it back over. There we go. We needed to do 13 times tangent, again, up and to the left of the division, of 56. Ooh, a negative. I didn't change back into degrees, so I'm going to have to go back and actually update that previous one. I apologize. If I were to come back here, see, this is why it makes a difference, because I was like, we shouldn't be getting any negatives. Let me redo that second, that 22 one. 22 divided by tan 61 is actually 12.195, let's call it. Oops. Makes a big difference. You saw me make it right there. 12.195 was actually the answer to the previous problem, which means this guy right here, if I do my 13 tan of 56, now that I'm in the correct mode, there we go, much more reasonable. 19.27. Sure, that makes sense. We'd expect it to be bigger than the 13. Okay, goodness gracious. That, you see what I mean? That was not planned. That was genuinely accidental. What are we at? 19.273. Let's call it 19.273. Rounding to 3 decimal places here. Make certain you're in degrees if you're using a calculator. Be very, very careful of that. The process is the same. Tangent's always the opposite over the adjacent. Great, we're going to throw some variables in there. We're going to do some algebra with it and ask you to find the other one. Nothing too crazy. All right. One common way that we use a lot of this trig is that we see, uh-oh, skipping frames. Let's hope it's not too bad. Well, hopefully this is coming through all right. Using these known ratios to find unknown measurements for things that would be real difficult to take. Basically, if you were to take any sort of like modern tool to measure things based on like elevation, it's just doing this math inside of it. So we've got, and these are just sort of the next examples as you work through the section of 9.4 here. We've got this sort of spruce tree here. We're trying to figure out the height. we can determine that it says we're standing 45 feet away from it, and it's an angle of 59 degrees. Find the height. Well, if we copy that same sort of setup here, I'm still going to say tangent of, my angle, which in this case is 59 degrees. That's always going to equal my opposite side, which in this case is h, over my adjacent side, which is 45 feet. And we're doing this whole thing in feet. This is basically the same algebra as that last one. What do I have to do to get h by itself? Multiply both sides by 45. If I do 45, it's going to cross cancel right here. Multiply 45 on the left side. Green wasn't the best choice. My apologies. I literally need to figure out what 45 tan of 59. 59 degrees is. That's going to be my h value. This is time for the calculator. There's not any thinking you can really do with it. You're not going to be able to come up with these numbers on your own. 45 times tangent of, put 59 in there and just hit enter. Actually really click it. How tall is that tree? 74.893 feet. That's how we're going to actually use this sort of tangent there. That's what, 74.893. 74.893. I'm going to put the units in just so we're keeping kind of consistent with that. There you go. It's always a relationship between the opposite side and the adjacent side, and the rest is just kind of doing some algebra to figure out an unknown. Let's try this guy, number 6. Sure, it should be example 6 here. Same deal, trying to find the height of a lamppost. Pause this guy, give it a try. We can see the you're 40 inches from the base to the lamppost, and it's a 70-degree angle. What do you think this setup is going to look like? Pause it, give it a try on your own, and then come on back. Definitely everybody 100% paused. At this point, we're going to have tan of 70. That's my angle. It equals my opposite side, which in this case is h, divided by, my adjacent side, which is 40. And in this case, it's inches. Be careful about that since the question's asking us for inches at the end. Not too much of a concern. Same sort of algebra as the last one. What do I do to get h by itself? Multiply both sides by 40 because it'll cross cancel the denominator. So what am I going to get? And what do I need to literally, come on, type into the calculator? 40 tan of 70 equals h. Since we put in inches, 40 inches, it's going to give us out our number in inches. 40. Not liking how quick I move with this. Times tangent of 70. How tall is it in inches? 109.899, and that 0 is going to stay right there. Great. So one more time, 109.899. I am going to put inches there in sort of the final answer. I know it's probably something you haven't thought about for a while, but considering writing sentences for those sorts of things, that's kind of what we're going to ask you to work your way through, okay? So, to prove that you watched the video and you made it through here, we're going to have another quiz. The phrase I need you to remember is apple pie cowboy toothpaste. Okay, there's going to be a bunch of nonsensical sort of writings and things like that. And I'm going to ask which nonsensical phrase did I say and was on in the slides. And it is apple pie cowboy toothpaste. I will say that a third time. Apple pie cowboy toothpaste. Look for a quiz around that. That quiz and the clever assignment are both going to be due by Sunday at like 11:50 because I basically have to do attendance like right after that. Please do it earlier. It's basically page 545, number 3 through 10, 15, and 16. Please do that through Clever. Make sure you hit submit at the end. Feel free to pop into office hours. Timing for office hours is not going to change, but the way you access it is. I've been told that I'm not allowed to have the links directly on the calendars anymore, so look to the Google Classroom for how to kind of access those. The times is going to stay the same. It'll still be sort of Zoom things. You're still welcome to join. You don't have to by any means. But yeah, there's sort of your stuff for 9-4. There might be another voluntary assignment coming through. If this assignment doesn't go so well when you like submit it and it's not as high of a score as you want, please ask some questions. Come into office hours and get some clarification around this, all right? Remember the phrase apple pie, cowboy toothpaste. I hope you're staying safe, healthy, and well, finding something new and interesting to do, cultivating a new skill or talent, or maybe building some good habits. And we'll hopefully talk to you in the future. Goodbye.